In this video, we will discuss 6 important facts about apophthegms and radii in regular polygons, and then we'll also try some examples using the regular polygon formulas that were discussed in the previous video. So some things that you should keep in mind about apophthegms and radii of regular polygons is that only regular polygons have apophthegms. All apophthegms of regular polygons are congruent. The apophthegm is the radius of the circle that is inscribed in the polygon. So what I mean by that is if we have our regular polygon, so let's just say we have this equilateral triangle, and then we were to inscribe a circle inside of it, and then we were to just inscribe a circle inside of it, and then to draw the apophthegm, notice that apophthegm is the radius of the circle that is inscribed in it. The apophthegm is the perpendicular bisector of a side of your regular polygon. So not only does it form right angles, but it also bisects the side that it's drawn to. The radius of the regular polygon is equal to the radius of the circle that is circumscribed about that polygon. So what do I mean by that? If I were to draw, for example, a regular polygon, so let's just say we have a square, and then I were to draw the circle that is circumscribed about that, the radius of the square is the same as the radius of that circumscribed circle. The last thing you need to know about apophthegms and radii is that the radius of a regular polygon is the angle bisector of that polygon. So when you draw the radius of your regular polygon, that is always going to bisect the angle, divide it into two congruent angles. So keep these things in mind as you're trying to solve different things involving regular polygons. So sometimes they'll give you the apophthegm, you may need to find the radius, they may give you the radius, you need to find the apophthegm, things like that. So what I'd like you to do is take a few minutes and try the examples listed below using the formulas discussed in the previous video. Now, as we have been discussing all the different formulas in Chapter 11, one area formula may be more convenient than another. So if we think about a square, we have several different area formulas that we can use to calculate the area of a square. So depending on what you're most comfortable with and the given information, you can determine which formula you would like to use to calculate that area. I'm going to show you how to use the new formulas for each of these examples, but if you did it another way and still got the same answer, that is completely fine. So pause the video now, take a few minutes, do the examples, and when you're ready to check your answers, press play to check. So the first one asks us to find the area of an equilateral triangle with a side of 4 centimeters. So since it's giving us the side, I feel that the formula that would be the most convenient to use would be the equilateral triangle area formula, which was equal to side squared root 3 divided by 4. The side is 4, so I have 4 squared root 3 divided by 4, and then when I go to simplify that, I get 16 square root 3 divided by 4. I know I can simplify 16 divided by 4. That's equal to 4 square root 3 centimeters squared. So my final answer for this first example is 4 square root 3 centimeters squared. Now for example 2, I have 4 different examples that ask me to find the area of the regular polygon, and I'm given the apophthegm in each one. So I'm going to use my formula apophthegm times the perimeter of my shape divided by 2. Now I'm given the apophthegm, but to find the perimeter I need to get the side of this hexagon. Now when I draw that radius, since it bisects the angle, I know this angle then becomes a 60-degree angle, so now I have a 30, 60, 90 triangle. The side across from the 60 is equal to x square root 3. And if I can solve that for x, I will be able to find the side of my hexagon. So I'm going to divide both sides by the square root of 3. I can't leave a square root in the denominator, so I'm going to multiply both the top and the bottom by the square root of 3. And I get 6 square root 3 over the square root of 9, or 6 square root 3 divided by 3, which reduces to 2 square root 3. That's equal to x, and I know x is across from the 30-degree angle. So if I want to find the entire side, since I know the apothem bisects the side of the polygon, this side would also be 2 root 3. So the entire side of my regular hexagon is equal to 4 square root 3. So to find the perimeter, since there are 6 sides, I'm just going to multiply this by 6 to get 24 square root 3 as my perimeter. The apothem was given, that's 6, and now I know the perimeter is 24 square root 3. And then I'm going to divide that by 2. And when I simplify to get my final answer, I get 72 square root 3 units squared as my final answer for the area of the regular hexagon. Similarly, if I look below, I'm going to use the same formula to calculate the area of my equilateral triangle. Since I'm given the apothem, I think it would be most convenient to use my regular polygon formula. So if I draw the radius and I know it bisects the angle, this now becomes a 30-degree angle. So I have a 30, 60, 90 triangle. I know the side across from the 30 is equal to x, and the side across from the 60 is equal to x square root 3. So I know since the apothem bisects the side, the other part of the side would also be equal to 12 square root 3. So the entire side of my equilateral triangle is 24 square root 3, and then to find the perimeter, I'm going to multiply it by 3 since there are 3 sides. So my perimeter of my equilateral triangle is equal to 72 square root 3, and the apothem was given. So I'm going to multiply 12 times the perimeter, which is 72 square root 3, divide that by 2, and when I go to simplify, I get a final answer of 432 square root 3 units squared. That's my final answer for the area of that equilateral triangle. Now going to letter C, I have a square, and I want to calculate out the area of this regular polygon. So if I use my regular polygon formula, I have the apothem times the perimeter divided by 2. If I draw the radius of my square, I know it bisects the angle, so this becomes a 45, 45, 90 right triangle. The side across from the 45 is equal to x, and so I know this side will also be equal to x, since it's across from the 45. Since the apothem bisects the side, the other side would be equal to 3 square root 2, and then the entire side of my square is equal to 6 square root 2. To find the perimeter, I'm going to multiply by 4 since there are 4 sides. So the perimeter of my square is equal to 24 square root 2. The apothem is 3 square root 2 times the perimeter, which is 24 square root 2. And then I'm going to divide that by 2. And if I go to simplify, remember that when you're multiplying square roots, you have to multiply the outside numbers together and then the inside numbers together. So 3 times 24 gives me 72. Square root 2 times 2 is 4. Divide that by 2. I know the square root of 4 is the same thing as 2, so this will actually just cancel out. So my final answer for the area of the square is 72 units squared. Finally, my last example here, letter D, this is a regular pentagon. So I'm going to use my area of a regular polygon formula and multiply the apothem times the perimeter divided by 2. To find the perimeter, I know each side is 6, and there are 5 sides. So 6 times 5 gives me the perimeter of this pentagon, which is equal to 30. So I have the apothem, which is 4, times the perimeter, which is 30, and then I'm going to divide that by 2. When I go to simplify that, I get 60 units squared as the area of my regular pentagon. Okay, now let's scroll down and try our last example here. In example 3, it says to find the area of an equilateral triangle with a side of 2 square root 3. So since it's giving us the side, I'm going to use the formula side squared root 3 divided by 4. And I'm going to substitute my side, which is 2 square root 3. I need to square that, then multiply by the square root of 3 again, and divide it by 4. Now, anytime you square a square root, I always say to write it twice. And then when you go to multiply square roots, you multiply the outside numbers together and then the inside numbers together. So 2 times 2 is 4, 3 times 3 is 9. I know the square root of 9 is just 3. So when I square it, 2 square root 3, I get 12. So this then would become 12 square root 3 divided by 4. I can simplify 12 divided by 4 to get 3 square root 3 units squared as the area of this equilateral triangle. So hopefully it's starting to make a little bit more sense as we've gone through some different types of examples, but please don't hesitate to bring questions to class tomorrow and we can go over anything that you have questions on.